हेलो अस्सलाम वालेकुम। कैसे हैं आप? ठीक हैं। आज जो है हम इंटरमीडिएट का एक लेक्चर डाउनलोड करने जा रहे हैं। पहले फर्स्ट लेक्चर के अंदर मैंने आपको हीट एंड वर्क और थर्मोडायनामिक के बारे में बताया था। आज का हमारा लेक्चर थर्मोडायनामिक से ही मुत्तलिक है, क्योंकि इस चैप्टर का नाम भी है फर्स्ट लॉ ऑफ थर्मोडायनामिक। तो फर्स्ट लॉ ऑफ थर्मोडायनामिक हम आज पढ़ेंगे कि फर्स्ट लॉ ऑफ थर्मोडायनामिक क्या होता है। फर्स्ट लॉ ऑफ थर्मोडायनामिक जो है कंसिक्यूसिव करता है विद द लॉ ऑफ कंजर्वेशन ऑफ एनर्जी। यू मस्ट नो अबाउट लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. Energy can neither be created, can neither be destroyed, but it can be changed from one form to another form. This is your first law of thermodynamic, law of conservation of energy definition. What first law of thermodynamic told us? First law of thermodynamic told us that heat is a form of energy and conversion of internal energy also we discussed in first law of thermodynamics. First law of thermodynamics example is bicycle pump. Bicycle pump is the example of first law of thermodynamics that convert heat energy into mechanical work. Because we know that when we convert heat energy into mechanical work, the gases can be expanded. This is maybe flow of heat from hot to cold or cold to hot. These flows come from due to temperature difference. And also, what is first law of thermodynamics? You must know about the definition of first law of thermodynamics. When heat is converted into work, which work will be mechanical work or other form of energy, the total energy remains constant. This is the definition of first law of thermodynamics, that when heat is converted into work or other form of energy, the total energy remains constant. You must know that delta U is internal energy. Internal energy depends upon temperature. If temperature increase, then also U increase, delta U positive. And also if temperature decrease, U decrease, and then your delta U will be negative. If temperature is constant, U is constant, but delta U is equal to 0. Delta U is the internal energy of the system. This is also definition of internal energy, that the total energy of the molecule, the sum of kinetic and potential energy of the molecule is called internal energy. Delta Q minus delta W, this is the general formula of first law of thermodynamics. Delta Q is heat energy. You must know that when heat is added to the system, heat is positive. If heat leaves the system, this is negative. If heat is added to the system, this is entropy is positive. If heat leaves the system, entropy is negative. If you must know that heat not enter or leave the system, this is isolated system. This system also called as adiabatic process. In this system, we can say that no entropy change occur in adiabatic process. Next one is delta W. Delta W is the work done. Work done is by the system, on the system. By the system is gases can be expanded. When gases expand by the system, and gas is compressed on the system. If gas is not compressed, not expand, then delta W is equal to 0. This comes from isobaric process, in which volume of the system remains constant. Also, these two formulas related with first law of thermodynamics, and you must now we discuss the applications of first law of thermodynamics. To discuss first law of thermodynamics, we have a cylinder or piston that move or not move. We can discuss here the application. The first application is isobaric process. Isobaric, iso mana same, baric mana load. We can say load is a pressure. If a system, a thermodynamic process in which pressure of the system remains constant, is called isobaric process. In isobaric process, system is movable. It means the pistons are moving. When pistons are moving, your heat energy can be converted into mechanical work. Also, gases can be expanded. Why gases can be expanded at constant pressure? Because you must know that when we supplied heat at constant pressure, the internal and external pressure will be equal. Then gases may be expanded. When gases expand, it means the system absorbs the heat. If system absorbs the heat, its work will be positive, because this is by the system work. And also you know that when systems expand, also internal energy is produced in the system when the gases can be expanded. This is isobaric process. And also you know that in isobaric process the system is movable. We know in first year that when we push something, that will be in displacement. After pushing something, they cover a displacement. This is the work done of the body. Then work is equal to F dot delta X. What is delta X? The delta X will be a displacement, but F is equal to, you must know that F pressure is equal to force per unit area, but F is equal to PA. Then we write here PA in spite of F delta X. And you must know that A is the area, delta X is the displacement, area is L square, displacement is L. L square multiply with L, this is L cube. L cube also dimension of volume. Then we can write here change in volume in spite of this one. You know that how you find change in volume. Change in volume means this is final to initial V2 minus V1. This is change in volume. But we know from general gas equation PV is equal to NR delta T. In this way we can write here in spite of P change in V NR delta T. Also NR delta T means T2 minus T1 final to initial, because these all pressure, volume, temperature, these all are property of system. Also known as these are the state variables. State variable must have initial and final position because they are come to the conservative. Also you know that delta QP is heat energy at constant pressure, delta U plus delta W. In spite of delta W, you write here P change in V. P change in V is equal to NR delta T. We can write here P change in V NR delta T because PV is equal to NRT in this equation. Also, delta QP is equal to delta U plus delta. This is final equation of isobaric process. In isobaric process, there are many examples of isobaric process. And isobaric pressure is constant. Heat engines operate can at constant pressure. Also, melting of ice can be come from isobaric process. Also, isobaric, many examples are come in isobaric process. This example of isobaric process is heat engine. This is pressure and volume graph that can be seen parallel to volume axis. P1 V1 T1, P1 V2 T2. It means pressure will be same, but volume and temperature will be changed. If volume and temperature both can be changed, we must know that if body's volume increase, pressure decrease, then gases will be expand. If volume increase, volume decrease, pressure increase, the gases will be compressed. This can be discussed in previous lectures. Also, this is the lecture that depends upon first law of thermodynamics, and its first process, isobaric process, in which pressure remains constant. In all things, we can see that heat energy can be converted into mechanical work. This is, I think, this is a simple process to understand how heat is converted into mechanical work. There are two processes: heat supply from hot to cold or cold to hot. These both supplied come due to temperature difference that can be discussed in a system. Why we use it, there is a system? Because system is anything in under observation. Now we are in under observation is a cylinder that can be discussed here. This is first law isobaric process. Inshallah, in next lecture we can discuss isochoric process, isothermal process, and adiabatic process. This is something to say about first law of thermodynamics and its first process, isobaric process. Okay, inshallah, in next lecture we come inshallah very soon. Please like and subscribe my channel. And okay, Khuda Hafiz.